All right, so as I said, we're going to finish up solving exponential and logarithmic equations. Basically, we'll be looking at logarithmic equations and then finding inverses of exponential functions and logarithmic functions. All sorts of fun today. The start, solving logarithmic equations. If there's only one expression with a logarithm, what we're going to do is isolate it, get it by itself using some algebra. And then we will rewrite that equation as an exponential, using the idea that the base to the power of what it's equal to is equal to the inside of the logarithm. And we'll look at that in a few minutes. If there's more than one logarithmic expression, what we're going to do is get them so they have the same base using either the change of base formula or our properties of logarithms, things like that, so that we can write it so we only have one expression with only one logarithm in there, and then we can go back up to step one and work them out that way. So here we go. We have the ln of x squared minus x minus 2 equals 1. And I believe for these, it asks for the exact answer. So they don't want, if you have an ln in there, you'll leave it as an ln. If you have, you'll see. We'll get there. So this one, remember, ln is log base e. So this means that x squared minus x minus 2 would equal e to the first power. They call it kind of that swoosh. Well, we have a quadratic on the left-hand side, and to solve the quadratic, we want to get it equal to 0. So if I subtract e to the first from both sides, I get it equal to 0. I'm going to rewrite this one more time. If I take that minus 2 minus e to the first and group it together and factor out a negative, I get that. And the reason I'm going to do that is to solve this, we'd actually need to use the quadratic formula. And so in this case, a is 1, b is negative 1, and c is negative 2 plus e to the first. Oh, Mr. Gingrich, can they all be like this? No, I'm actually picking, this is one of the few times Mr. Gingrich has taken the most difficult example, and we're doing that in our notes, all right? It's about time, Gingrich. Oh. All right, so if we use the quadratic formula, we get the opposite of b, which is 1, plus or minus the square root of b squared, minus 4 times a times c. Oh, man, I'm going to be in trouble here. Let's see. All over 2 times a. So we're going to simplify this a little bit, but not very much. See, you guys let me do this stuff. That's squared, not to the fourth power. I was thinking about the 4 that was coming next, I think. This negative and the minus, and I cancel each other, becomes positive. And so if I distribute that 4 through, I get 4 times 2 is 8, plus 1 is 9. And then 4 times e to the first is 4e to the first. And because e is an irrational number, I'm not going to be able to get a integer or a decimal answer. So I would leave it like that. All right, so they're all easier from here, maybe. Log base 4 of x minus log base 4 of x plus 1 equals 2. So here we have 2 logarithms, but they're both base 4, which is nice. So I'm going to use the fact that I have subtraction, and subtraction of 2 logarithms of the same base means I can take the first logarithm and divide it by the second. That sound familiar? All right. And then, like I said, we can use the fact that this means I take 4 to the power of 2, and that has to equal, that's why they call it the swish method or the swishy method, or I forget what the textbook. So x over x plus 1 is equal to 16. And multiply both sides by x plus 1, distribute the 16 through. Subtract the 16x from both sides. Divide by negative 15. Now with any time you're solving an equation, it's always a good idea to go back and check. So if I took negative 16 over 15 and I plugged it in, we'd have a problem because we can't take the logarithm of a negative value. So because of that, negative 16 over 15 is not a solution. And in this case, we would have no solutions. So you always do want to check. and always check back to the original equation. If I use that other equation, I would get, if I use the logarithmic, this log of x over x plus 1, I would actually get a true statement, because it would be a negative divided by a negative, make it positive, and then I can take the log. So just be careful with that. All right. All right. So that's solving logarithmic equations, and probably two of the more unusual cases. So I did want to make sure to cover that. Then we have inverses. So again, the first thing I would do is rewrite this instead of f of x, write it as y. And if we're finding the inverse of a function, we switch the x and the y, and then solve for y. And then just so you know, I think all of the examples in the book that start with a logarithmic function are all ln, so all log base e. It just makes it easier. If we start with a logarithmic function, we're going to get an exponential function as its inverse. If we start with an exponential function, we're going to get a logarithmic function as its inverse. So always good to know. I would add 1 to both sides. Divide by 2. I left just about enough room. The ln, remember that's log base e. So we use the little swishy thing, and we would get then e to the power of x plus 1 over 2 is equal to 3y. Then dividing by 3 or multiplying by 1/3. We get our inverse. Whew, that was fun. Better than solving. All right, the last one here is an exponential. So again, y equals 2 plus e to the x minus 2. Switching my x and my y. Solving to get the y alone. Subtract 2. Now what we're going to do is take the natural log of both sides. And what happens when we do that, the ln and e are inverses. They cancel each other out. We're just left with whatever the exponent is. So the left-hand side, ln x minus 2, would be equal to y minus 2. Then to get the y by itself, we add 2. So the parentheses are kind of important, so that we know that 2 is not inside the ln, that plus 2. And that's it. That's the inverse. as I said, we'll finish up, the last section is on exponential growth and exponential decay. We'll finish that up this week, and then review. And what I hope to do is post the review maybe over the weekend, but if you need time, we can certainly take some time, answer any questions during class on Monday, and you can have time to work. Tuesday, I'll answer any questions you have, and then we'll test on Tuesday for you guys.